Good morning. This is Kasturi Day. Today I'm starting with a new chapter according to ICSE syllabus class 8 light energy. Okay. So we know that light is a form of energy. We have started in the energy chapter that light is a form of energy. Okay. So in class 7 we have started with the reflection of light. Okay. So I'm repeating some of them, some of the important points of this reflection of light. Okay, so what is reflection? Reflection is the ray of light after striking a mirror. When a ray of light after striking a mirror or any other polished surface comes back in another direction, okay, another direction, where the angle of incidence is equal to angle of reflection, where it becomes that angle of incidence is equal to angle of reflection. That is known as the reflection. Okay, that is reflection. For this, there should be an incident ray. Incident ray is the light ray which is falling on the mirror. Okay, and after reflection, the ray is striking back from the mirror. That is the reflected ray. The perpendicular, which is drawn at a right angle of 90 degree with the incident ray as the normal, is the normal. Okay. See, from the picture you can see the incident ray which is striking the mirror, the ray which is striking the mirror, that is the incident ray. After striking the mirror, it goes out, comes back from the mirror. That is the reflected ray. The normal is 90 degree. The ray which is perpendicular striking at an angle of 90 degree with the incident ray, that is the normal. Okay. Then the angle of incidence, which is represented by angle I. Okay, angle I. So that is the angle of incidence, which is the angle which is made by the incident ray with the normal. Okay, the angle formed by the incident ray with the normal, that is the incident angle of incidence, that is angle I. Okay, small I. And then angle of reflection is the normal which is making with the reflected ray, the angle which is making with the normal and the reflected ray, that is the angle of reflection, which is represented by angle small r. Okay, this is the reflection of light. Okay, now there are two laws of reflection we have studied there. That's the first law, that is angle of I is equal to angle of R. That is angle of incidence is equal to angle of reflection. And the second law was that incident ray, reflected ray and the normal at the point of incidence all should lie in the same plane. Okay. So in class 7 we have studied with the plane mirror. Okay, it was a small polished surface which can turn back the rays of light into the same direction. Okay, in this reflection, that the ray which is striking the mirror, that comes back in the same direction but making an angle which is equal to the angle of incidence. Okay, so next is we come in this class 8, we are studying with refraction of light. Okay, so what is refraction? First is, what is refraction of light? Here, the change in the direction of path of light when it passes from optically transparent medium to another medium, another optically transparent medium. Okay, what happens? Here, the ray of light passes from one transparent medium to another transparent medium. Here what happens? The ray does not come back in the same, in the same media or same medium, but it passes through the other medium after striking it. Okay. So that is refraction of light. Here there are laws of reflection that is known as Snell's law. What are the laws of reflection? The incident ray, the normal at the point of incidence, and the refracted ray all lie in the same plane. Like reflection, the incident ray, the normal at the point of incidence, and the refracted ray, that was reflected ray, here it is refracted ray, all lie in the same plane. Okay. Next is, for a given pair of medium, see, there should be two mediums. Okay, two medias should be there. In reflection, only one medium was there. But here, two medias are there. In refraction, two medias are there. So, in a given pair of media, if the media changes, the refraction of light also changes. So, the given pair of media should be mentioned. Okay, so for a given pair of media, and a given color of light is also important because different colors has different angle of refraction. So different wavelengths, different many things are different, so I'll discuss later on. So first there should be given pair of media and a given color of light. The ratio of sign of incidence to sign of refraction is constant. Okay, sin I by sin R is equal to constant. Okay, I'll discuss what happens in the later on. First, let me tell you what is the rule, what are the rules, okay? Now, the constant is denoted by a symbol mu. Okay, this symbol, U symbol, that is known as mu with respect to the media. Okay, its mentioned is mu. Now, a refractive index of the second media with respect to first media. Okay, this is known as refractive index of the second medium to the with respect to the first medium. And mu is equal to speed of the light in the first medium by speed of light in the second medium. For example, if a ray of light travels from air to water, see one medium, air, water is the second medium. So two medias are there. So light is traveling from air to water, mu is equal to sin I by sin R. Okay, and excuse me, this is the refractive index of water with respect to air. See, Snell's law, I have given this formula I have given here. Just check it. Sine angle of incidence by sine angle of refraction, that is equal to constant, and that is the refractive index we call it. That is denoted by mu. Okay. Next is refraction of light. See, this is also a continuation of that topic. This mu is equal to sin I by sin R. For example, for air, it is 3 into 10 to the power 8 meter per second. Yes, for air, it is 3 to 8 to air to glass. No, so that is for air to glass, it is 3 into 10 to the power 8 meter per second by 2.25 into 10 to the power 8 meter per 8 meter per second, that is equal to 4 by 3, 1.33 is the answer. So air to glass, this was water to air to water. This is air to glass, okay? 3 into 10 to the power 8 meter per second. Glass is 2 into 10 to the power, yes, 2 into 10 to the power 8 meter per second. That is equal to 1.5. Because sin I by sin R, it's a ratio, so there is no unit. Note, the refractive index of air is 1. Okay, and no medium can have refractive index less than 1. That is impossible. Okay, so next we come to effects of refraction. What happens for after, why this refraction of light is so important? What are the effects of this refraction? See, when we look from if we take a bucket of water, we see that the depth of water is slightly raised up. We see, no, that is the bucket, the lower of the bottom of the bucket is higher, raised up, that we see. So this is because of refraction. Like that, the depth of water in a vessel when seen from air appears to be less. A stamp which is placed under a thick glass, if we place a stamp under a thick glass, we see it to be raised. Even the stars appear to twinkle because of this refraction. When we sit around the campfire, the face of the person sitting opposite to you, if we sit around the fire, see the face of a person who is sitting opposite to you, they may appear to shimmer. Why? It is because of refraction. Even the swimming pool, when filled with water, it appears to be shallow. The bottom of the swimming pool becomes to be raised up, but it may be deep, very deep. Okay, this is all because of refraction. Next, we come to the rules of the deviation of rays in another optical medium. See, there are certain rules why what happens when from one media when the light passes from one medium to another medium. Okay, so there are certain rules of deviation. What happens when the light rays passes from one medium to another medium? How much does it deviates? Okay, so there are certain rules. First rule is when a ray of light travels from a optically dense medium, say air, to optically more dense medium, less dense to more dense like glass. Okay, so from less dense to more dense, that is air to glass, air is less dense, glass is more dense. So it bends towards the normal. See from the picture, air to glass, this is the normal line, the dotted line, that is the normal line. This is the incident ray which is striking the surface. When it is entering the glass, it bends towards the normal. See, angle of incidence is more than angle of refraction. So the refracted ray bends towards the normal, at the surface of separation of two media. Okay, but when a ray of light travels from optically more dense mediums, that is from glass to air, if it comes out, what happens? It bends away from the normal at the surface of separation of two media. See, in this second case, you can see that the angle of incidence is less than the angle of refraction. That is, angle of refraction is more. Okay, so this is the case. These are the second rule. Third rule is if it strikes straight, that is, if the angle is 90 degree, if it strikes straight 90 degree, if it is striking it, it will not bend. Okay, it will strike and come out without deviation from the path. Okay, so angle I is equal to 0 and R will be equal to also 0. Okay, so these are the three rules of this deviation. Okay, so please go through this. If you have any doubt, please let me know. Please do write in the comment box. And if you hope you are liking the videos, press the like button, share with your friends. And if you are suggesting any improvement in my videos or any other subjects to be informed, please do let me know. Please do write in the comment box. Okay, and another announcement to make, I'll be launching a website very soon. Okay, so that will help you more, and more information regarding these subjects as well as different other subjects will also be helping you even in your general knowledge also. So wait for that, and please do subscribe if you have not subscribed yet, and if you are a new viewer, please do subscribe. Okay, thank you so much.